How is everyone doing? Well, yeah, I'm unfortunately cannot make it in person, but really happy to be here talking to all of you over video. So I can only see my. Okay, I see the slides now. Great.
Perfect.
Okay, so this is going to be the same talk that I gave at VConf a while ago, but I figured um, this is the thing I've mostly been focusing on for the past few months, and I do think it is important to get the message through, and this has impact on Vue and related ecosystem as well, obviously, because most of Vue tooling is now based on Vite. Nux is based on Vite. So any improvement to Vite underneath will greatly impact the development experience of Vue users. Okay, so here we go. Okay, let's see if I can get the clicker going. All right, cool. So um, first of all, a quick look at how Vite growth has been. So compared to last year's around this time, we've already doubled, more than doubled in terms of download count, and we're now at over 15 million weekly npm downloads. This is still actually not quite the largest number we can get because compared to some of the older tools like Webpack or Babel Core, this is we still have lots of room for growth, but we're on a really good trajectory here because um, from last year's State of JS survey, um, which is actually the latest one. Both Vite and Vitess got a lot of recognition from the community. It is Vite got the most adopted, highest retention, highest interest, and Vitess also got very high ranking in those categories. So both projects almost basically top the charts in every possible category, and Vite won most loved library overall. So I'm sure a lot of Vue users are have probably casted that vote in favor of Vite and Vitess as well. So outside of just Vue support, obviously, Vite is now growing into something of a larger ecosystem. It is now kind of like a coalition of the next gen web frameworks and tools. In fact, the only thing that's not on Vite nowadays is probably Next.js. But outside of that, we do see not only frameworks, but also test runners, package managers like Tari, which you can use it in combination with Vite to build desktop apps. Laravel has first-class Vite integration. Ruby on Rails. They don't have an official one because Ruby Rails decided to go full no build, but the Rails community members they've built a great integration called I believe it's called Rails Vite or Ruby Vite that you can easily integrate Vite into Ruby on Rails as well. And there are Playwright tools like Playwright, Storybook that are more supporting roads in the tooling ecosystem, but they have first-class Vite integration. So Vite has become the shared infrastructure layer for the next generation of web applications. And that is a pretty bold statement. I think last year, if we said this, it would be a bit premature, but now I think it is becoming more and more of a reality. So that also places a lot more responsibility on us, on me, on the Vite team, and everyone working on improving Vite, because Vite is not perfect, and I would be the first person to acknowledge that. So, um, so this sort of trust and you know um, people's enjoyment of Vite kind of pushed me to think about like what can we do to make it better, right? So, in order to think through that, I think the primary reason people love Vite is because it makes web development feel simple again. So. Let's say you want to start a new Vue project, you're mostly just using Vite plus the official Vue plugin, right? You no longer have to configure a ton of other plugins or write a hundreds line long configuration file in order to get things going. And it's lean, it's fast, it's easy to understand what's going on. But underneath, Vite is able to kind of hide a lot of complexity uh, to the end users because we do handle a lot of additional build steps underneath, and we rely on dependencies to do that as well, right? So the three primary dependencies that Vite relies on are ESBuild, Rollup, and SWC. So the problem with this current architecture is, although it works, it creates a lot of inefficiency. So let's look at that one by one. First of all, the reason Vite uses ESBuild underneath is because we use ESBuild to pre-bundle the dependencies during development. Because ESBuild is fast. That's the main reason. It is extremely fast. It's the fastest. It's the fastest bundler that we know before Rodan appeared, right? So the downside of ESBuild is that it has very limited chunk and tree shaking control. Its tree shaking bails out in a lot more cases than Rollup does. Its chunk splitting has no configuration, so you can't really control, like, say, I want to avoid hundreds of small chunks with ESBuild, right? So it has limited flexibility in its plugin ecosystem as well. And it has no built-in React refresh transform. So we also use ESBuild to transform TypeScript and JSX by default, but unfortunately we cannot use it for everything, right? So it's a great tool. It does a lot of things really well, but it just have a few things that it just doesn't have and doesn't want to implement. And there's really no way for us to sort of make that happen. Like we actually try to want to look at how we can contribute some things back into ESBuild or even fork it. Unfortunately, ESBuild's internal architecture is designed in a way that is multiple layers of concerns mixed together. And it makes it quite difficult for external contributors to understand what's going on and keep things maintainable. And its maintainer, Evan Wallace, although doing a really great job, is very strongly opinionated. So in some cases, it might not be easy for us to get exactly what we want in ESBuild. So next up is Rollup, right? We use Rollup in Vite for production bundling. Rollup is great because it has a very mature plugin ecosystem. It is very battle tested for production bundling in terms of handling tree shaking. Rollup probably has one of the best tree shaking capabilities for pure ESM, and has a decent level of chunk asset control. Okay, so and most importantly, its plugin system is so much simpler than Webpack's. We believe this makes the barrier of entry for writing your own plugin much easier. So we modeled V's plugin system on top of Rollup's interface, right? So the biggest drawback of Rollup, obviously, is it's written in JavaScript. So the build speed is slow compared to native. It can be orders of magnitude slower than ESBuild, for example. And then there's SWC. We do not rely on SWC directly in Vite, but for a lot of React users, as I mentioned, ESBuild does not ship React Fast Transform. So for a lot of React users, they actually have to either use Babel to transpile their React components and have hot module replacement, or they have to use SWC, right? So Babel is really slow. So a lot of them opt to use SWC for that. But the end result is, for a typical React app built with Vite, they are using ESBuild, Rollup, plus SWC all in the same project. Not ideal, right? So first of all, because ESBuild is used for dev bundling and Rollup is used for production bundling, there can be some level of bundling behavior inconsistency. And this mostly happens when you have a lot of mixed ESM and CJS dependencies, or you have dependencies that are weirdly transformed from, for example, the code is written in ESM, but then compiled into CJS that pretends to be ESM. There are a lot of weird cases in there, right? So ESBuild and Rollup kind of handles these edge cases a bit differently. And that can be quite annoying if you only catch the problem in production. Another aspect of it is all these three tools have different parsers, right? So the same piece of source code in a production app can potentially go through 4 to 5 different parse, transform, serialization passes. So for example, it can first be processed by ESBuild for TypeScript transformation, and then process by rollup for actual bundling, then SWC for minification, then ES build again for target lowering. So this kind of inefficiency is it adds up over time, right? So a system that eliminates this inefficiency and handles all the tasks in one system would be much more efficient, right? The worst case here is not only are we paying the cost of repeated parse and serialization, we're also passing big chunks of strings from Go to JavaScript to Rust and back and forth again, right? All this little overhead adds up and can make your build significantly slower than it should be. And finally, the network bottleneck of unbundled ESM during dev. So this is a problem that has existed fundamentally because of Vue's unbundled ESM dev server. So it works well enough up to a certain threshold, right? For example, if you have fewer than 1,000 modules outside of your dependencies, only source code, right? It probably works just fine. But in enterprise projects or some really large SPAs, there could be like 4,000 to 5,000 of unbundled modules that we need to load over the dev server. And the network overhead just adds up, and it can make the page load quite slow. For example, it could take like 5 to 6 seconds to load the page when you first start the dev server. And it also kind of creates an issue where when you have the dev tools open and you have the network tab open, or you ticked the disable caching in your networks pane. It kind of all affects the unbundled dev server network speed. So we've tried many different things, try to work around this. Unfortunately, this bottleneck exists at the browser networking level, and there's no simple direct answer to it. There is an ongoing ES spec called module declarations, previously called module fragments, that might help us provide a way to help us solve this problem, but it is still at a relatively early stage, and it will take a very long time for this kind of things to eventually land in browsers natively. So we cannot really rely on that in the short term. Okay, so how to actually solve these problems, right? The first reaction we had is, okay, we need to unify the bundler and the transformers that we use. So enter Roda, right? So we start working on Roda, and in order to better support Roda and handle all the tasks consistently, we landed on OXC. And as we also worked deeper with Roda and OXC, we realized, okay, like why do we stop at the bundler, right? OXC has the potential to tackle a much larger problem scope than what a bundler would do for Vue. So the realization was that the challenge Vue is facing is a reflection of the JavaScript ecosystem at large, right? Not only in Vue, but in almost every production app that we have today, we probably rely on hundreds of third-party dependencies in order to solve different things. And this historically is because JavaScript evolved from a simple scripting language that was only meant for simple things into a powerhouse that it is today, right? And as we use JavaScript to build more and more ambitious apps, the demand for better engineering practices arises. And in order to support those engineering best practices, people come up with all kinds of tools and open source projects. Unfortunately, there was no centralized team to design such a coherent system for JavaScript. It kind of just all happened decentralized, right? So it's a blessing and a curse because it kind of is able to leverage the community's creative power to solve all these things differently. And through competition, we eventually land on some good solutions. But the sad state of affairs is that for a lot of these different tasks, right, all these dependencies are fragmented. There are incompatibilities, fragmentation, inefficiencies. So I really wish we can, change this for the JavaScript ecosystem, not just for Vue, but for all JavaScript work. If we can make things more efficient by having a unified toolchain, right? That would be great. And that is the reason why we are working on it at Voice Zero. So the vision for a unified toolchain for JavaScript, I came up with 4 things that I think are really important. The first is it needs to be unified, right? One AST to rule them all. We want one AST that starts from the parser. We want to use the same AST for linting, for transforms, for bundling, and uh, in fact, there are a lot of shared things we need to do between, say, linting, transforming, and bundling. We all need to do semantic analysis. We need to understand like the variable declarations, the function scopes, how they're nested, what variables are declared in what scope, how many references they have, are these references exported from the current module scope, and all that, right? So all of these analyses are actually very common. So not only the AST, but the semantic analysis is also a big chunk of work that can be shared across these different tasks, right? So a unified toolchain has even more benefits than AST reuse. And the next is it obviously needs to be really, really high performance, right? Tools written in JavaScript no longer cuts it, and that's just a fact. So, but where do we split the line, right? So I've always held the view that we need to move these well-defined, slower-moving targets to be handled by native languages. For example, parsing JavaScript and TypeScript. These are slow-moving targets. They are really well-defined problems. The spec changes really slowly, so it is easy to catch up once you catch up with the current standards. And transforming TypeScript is also one of those tasks, right? So these tasks can and should be written handled with compiled to native language, for example, Rust, right? And the reason we go with Rust is because Rust, as an ecosystem, has probably the most active package ecosystem and tooling that already exists for JavaScript, right? And we have an easier time finding people who are passionate about tooling in the Rust ecosystem compared to something, say, like Go or C++, right? And next thing is the toolchain needs to be composable. Being composable means it should not be a black box, right? So as I said, an example is that ESBuild is great. It has a lot of functionalities, but it's kind of a black box because the reason ESBuild is able to achieve the speed it has is because it just mixes all these different concerns together in its code base. And its parser, for example, you cannot just take out ESBuild's parser and use individually for other purposes. And we want to build something that is as fast or even faster than ESBuild, but still allows you to pick and choose the individual pieces. So you can use OXC's parser, you can use the linter, you can use the transformer or the resolver without having to opt into the whole thing. And finally, there's the runtime agnostic part. For example, there's runtimes like Bun or Dino that comes with their own opinionated tooling, which is great development experience boost for the people who decided to use a specific runtime. But a lot of times, you may not have the ability to just switch from Node.js to one of these newer runtimes, or you may have to. You cannot assume that your code will run on a specific runtime. Maybe your code will run in a work environment, or you're shipping a package that should run in all of these runtimes, right? So if we want a unified tooling for the entire JavaScript ecosystem, then this toolchain should not be coupled to a specific runtime. It should be able to help you no matter which runtime you expect your code to run on, including browsers as well. So isn't this too ambitious? Well, maybe. So that's why I founded the company Voice0, and we've raised quite a bit of funding in order to help us pursue the vision. So the investors truly believe that this is something the JavaScript ecosystem deserves and needs. And we're obviously going to work really hard on making this happen. And this is not going to be a short-term project, right? It's going to take years of hard work. So we're here for the long run. So the big picture here and what we want to really achieve in the end is that Vite, so OXC will be at the bottom. It's the language toolchain. It consists of a group of composable NPM packages and Rust crates that includes the parser, semantic analysis, transformer, minifier, resolver, linter, and formatter. And OXC will power Rowdown. Rowdown will be powering Vite. Vite will be powering VTest. And eventually Vite and VTest will be powering the higher level frameworks on top of them. So the progress so far. First is OXC, right? So OXC we already have completed the parser, the linter, and the resolver. So all three of these are spec compliant, full compatibility with existing standards or de facto standards. For example, the linter is compatible with the ESLint. It has ESLint A compatible configuration, 400 plus ESLint compatible rules. Um, we haven't really opened up the plugin system for the linter yet because it ties into a bigger problem about how to best offer JS plugins that can stay performant when it's used in a Rust core, right? So we have some ideas on how to make this as efficient as possible, but so we don't want to prematurely open up a JS plugin API because that would, if we open up a JS plugin API now that allows people to write arbitrary JS plugins that can slow down the whole system, then there's no chance of coming back from that. So we want to be really careful about this. That's why the linter currently does not allow custom plugins just yet. So we want to really get that right. So the current focus is on the transformer part, right? So we already finished the TypeScript transforms, React.js transforms, and isolated declarations transform. So this one is interesting because it's a recently new added feature in TypeScript that allows you, if you turn on the isolated declarations option in your TS config, then you can use OXC to directly emit definition files from your TS files without going through TypeScript itself. So it becomes a pure syntax transform. So this allows you to generate DTS at a fraction of seconds, like 15 milliseconds or something, right? So that's orders of magnitudes faster than TypeScript itself. So TypeScript also shipped a new method called transpile declarations only, I believe. But OXC is at least 14 times faster than what TSX does, right? TSC does. So right now, the only part that's left in the transformer is syntax lowering, i.e. converting your ES 2020 syntax down to ES 2015. And that's just a chunk of work that we need to do, and we're already making good progress. So likely this will be finished in Q4. And after that, there will be the minifier and the formatter. These are two large pieces left. Both of them already have prototypes. In fact, the minifier is already in Rowdown. It's just we haven't really fine-tuned all the possible minification options yet. So right now, the quality is probably like 90%, 80% of other minifiers, but the speed advantage is huge, right? So for the formatter, we leave it to the last because we know there's already Biome in the ecosystem that people can rely on in the short term. So we're not really in a hurry to kind of directly compete with Biome, but eventually we'll get to that so that people already using OXC for other things will be able to have a formatter that's compatible with OXC as well. So now performance, right? So this is probably the most important part. OXC, for everything that we built so far, OXC is probably the fastest that we know. So the fastest parser, linter, resolver, and transformer. So I've attached benchmarks in the slides. You can check them out later at your own pleasure. And in addition to just pure performance, there are some other interesting metrics that I think people should look at. One is memory usage. OXC transform uses less memory than both Babel and SWC, and notably, the binary size, which is often overlooked, but we actually do care a lot about it in Vite, is we don't want your node modules to keep growing to be huge. We care a lot about the number, the bytes you have to download. For example, when you run something on CI or in GitHub Actions, that actually makes a difference, right? And OXC transform is less than 2 megabytes in terms of binary size for Mac OS, right? Compared to SWC, which is 37 megabytes, right? One of the reasons we don't use SWC by default in Vite is because SWC's binary size is more than twice the size of Vite, and all Vite's dependencies included, right? So we do care a lot about that. And OXC kind of is fundamentally better in this regard. It also compiles a lot faster than SWC, so it makes our life developing Rowdown a lot easier as well. Okay, so now talk about Rowdown, right? So we've already done basic bundling, OXC integration, and advanced features like tree shaking. We have 90% roll-up plugin compatibility. So right now, the only things that's not compatible are really the niche features that you probably won't use yourself anyway. And a lot of the built-in, lot of the official rollup plugins are either compatible or are no longer needed because Rodon already handles them internally. For example, Node Resolve or Carbon.js handling, Rodon just does that out of the box, right? So right now our focus is on adding a first-class CSS, HTML, and SS support to Rodon so that we make it a general purpose bundler, not just for JavaScript. And the reason we want to do that is because we are also, in parallel, integrating Rodon into Vite. And when we're integrating Rodon into Vite, what we discovered is that Vite has a lot of internal JavaScript plugins, and there are probably 20 of them. So when you add a lot of JavaScript plugins to a Rust-based bundler, it slows things down significantly because every plugin involves multiple calls between Rust and JavaScript and passing data back and forth. And that cost adds up. And it also blocks Rust from its parallelization, right? Because JavaScript is single-threaded. So we've been experimenting with ways to make that faster, but the most fundamental and direct way to speed things up is to port the JavaScript plugins over to Rust. So we've been doing some of that, and we've been able to achieve significant performance gains by doing that for production builds. And in part of that, we are also trying to port the CSS plugin and HTML plugin, SF plugin in Vite over to Rust. And when we're porting those, we realize, okay, there's some fundamental architectural difference that between what we want to do, between what Vite is trying to do and what Rollup allows for. Because Rollup is originally designed to be a pure JavaScript bundler. Everything in Rollup is eventually converted to JavaScript. It does not have really the first-class concepts about CSS, HTML, or assets. Everything is treated as kind of an afterthought, right? So we want to make Rodon on top of being compatible with Rollup, but also have first-class citizen support for these additional web assets so that we have a cleaner implementation and better performance in the end. So once we finish these, we will be polishing up Rodon for 1.0 beta. So there's still a ton of work to do because building a bundler is not easy. We have to make sure it stays fast, make sure it's maintainable, make sure all these features align with existing solutions. So, but hopefully we'll be able to get to beta status later this year, hopefully by end of year. Okay, so performance, obviously. This is a benchmark bundling 19,000 modules. We're using React.js components because that is the one that doesn't really require any plugins. So it's standard across all these different build tools. So Rodon is able to bundle 19,000 modules in 600 milliseconds, 630 milliseconds, which is the fastest, almost twice as fast as CS build. So this depends on the machine you're running on. For example, if you run it on so this result actually comes from a machine with a lot of cores. If your machine has fewer cores, the difference between Rodon and AS build probably shrinks a bit, but still it doesn't change the fact that Rodon is right now the fastest bundler that we know. I also benchmarked it against Bun's bundler, and Rodon is faster, at least on my machine. So a case study that we do is we actually have successfully used Rodon plus OXC to bundle Vue itself, right? So in Vue 3.2, our build setup was all in JavaScript. And it was also not efficient. We're running TSC for every subpackage, and that results in almost a 2 minutes long build. In 3.5, I actually did, in 3.4, I believe, I did a major build system refactor. So we migrated over to using ES build for the TypeScript transforms. We used SWC for minification. We also used a different rollup plugin for DTS bundling. So that cut everything down to 8.52 seconds. Which is actually great, right? That actually accelerated things a lot for Vue's development. But with Rodon and OXC, we shaved that down further by more than 8 times, right? So the whole build now, including DTS generation, takes a bit over 1 second. And this is also before that we merge the DTS bundling capability into Rodon itself so that we don't need to do a separate pass to do OXC transform and do DTS bundling, right? In the future, Rodon should just handle this all by itself without any need of additional tools. And that will take way less than 1 second. It'd probably be just 600 or 700 milliseconds for entire Vue production build. So we're hoping to make this happen soon. Actually, also to note that the bundled output of this, we verify its correctness by running through the generated packages, running the Vue ecosystem CI with these generated packages. So we actually have a dozen downstream projects, including projects like Radix Vue, Vuetify, Vue macros, and Nuxt also, right? So we run the generated bundles against those downstream dependencies, run their tests, and the tests are passing, just like on the main branch. So we use that to verify the correctness and tree shaking efficiency and everything in Rowdown to make sure we're dogfooding all the implementation details. Okay, so that's a lot for the progress. And what is next? So the first thing that I want to talk about is the 3 stages of Vite that we can envision from now to the near future to the longer future. Right? So right now, this is Vite, and the upcoming version 6 is currently in beta, and the biggest change in it is the environment API. So that is a relatively low-level change, which does not really affect end users. It's an API designed for framework authors, building full-stack frameworks on top of Vite, right? Once we ship that, and this is the current architecture, most of the logic in Vite itself is in JavaScript, and we rely on a bunch of third-party dependencies. So in the next version of Vite that we hope to ship early next year is the JavaScript core stays the same, the unbundled dev server stays the same, but we swap all the dependencies with vertically integrated Rowdown and OXE stack, right? So now all the tasks that we perform in Vite are standardized and unified. From transforming to bundling to minification, they will be all handled by the same tool, right? So there's no more inconsistencies between rollup or ESBuild or SWC. And this should also significantly improve the production build performance, probably by more than 10 times, I would imagine, for a lot of apps. And finally, the Vite future, which is currently in prototyping stage, is we will then move part of the logic that we currently handle in Vite's JavaScript side over to Rowdown. So the Rust side will play a slightly bigger role because some of the APIs in Vite right now are stable enough that we can re-implement them in Rust in order to get better performance benefits, right? So another important aspect of this will unlock the full bundled mode, which allows us to opt into a bundled dev server, kind of like what we would do with other bundlers right now. But the benefit of this is you have a particularly large app with, like, say, thousands and thousands of unbundled modules. This will allow you to get back to just a few network requests and make your page load instant. And also, this would give you better consistency between development and production build. It would also get rid of issues concerned with depth optimization. It will get rid of SSR externals. It will essentially remove a whole category of problems that are Vite specific in its current model, and bring us back to a simpler mental model when it comes to development and production differences. Right? We would also use the same bundling to power the environment API, so that the SSR side of things would also see a big speed up during development. So that is the longer term future. This one is currently in early prototype, but it's showing great promise because we tested Rowdown in bundle mode, and the startup time and the hot module replacement time are way ahead of other known solutions. So the future of Vite will be bright, and it will stay the fastest possible solution for all your web build tool needs. Okay, so that's all. Thank you very much. And hopefully you'll be enjoying some of these things we're building right now in the next few months.
Evan, thank you so much for the wonderful presentation. Let's get
Thank you.
into the Q&A and some questions. Once again, if you have some questions, either submit them through the QR code you've seen before or raise your hands, then we'll have some mics. And let's stay with the whole topic of the unified JavaScript system toolchain. Someone is asking here, are you coding in Rust yourself, or how do you make sure that the code quality of Rolldown and other Rust-based tools are in a good shape?
So I honestly don't write much Rust code, but we have the team that we have founded, we have assembled are probably some of the smart people that I know, right? People who have previously worked on RSPack, people who have contributed to SWC, and Borschen I've actually been keeping track of Borschen's work since very long ago. OXE has always caught my eye in terms of its code quality and how obsessed with performance Borschen is, right? So when I talked to, before we founded the company, I actually talked to some of the team members that are now with us today, and to get their opinions on some of the Rust tooling, like their experience working on RSPack, their experience working with SWC. So I would say I do a lot of research to determine what are the good engineers who can write the desired toolchain that we want. But as a team, my job at the company is mostly to find the right people to do the right job and secure enough funding to support their work and set the vision, coordinate all the work to make sure we are moving towards our goals.
Totally makes sense. Thanks. And talking about the vision, so someone was also asking, can you maybe briefly share how it happened that from creating a front-end framework like Vue.js, you went over to Vite and now to that unified JavaScript toolchain eventually?
Right. I think it's it's very clear picture of me scratching my own itch. Right. I created Vue because I wanted a framework that I enjoyed myself. And in order to make Vue better, I started building the toolchain around it. So initially, I built Vue CLI, which was based on Webpack. And over time, I realized there was a lot of bloated abstraction. It was difficult to maintain, which led me to think about how we can simplify this and eventually created Vite. Right. So, and from Vite to the company and the tooling, really, I basically talked about it in the talk, right? It's a process of us thinking about how we can improve Vite more fundamentally and realizing it's really a bigger problem that needs to be solved. And if we find the right people, get enough resources, we can actually make it happen. Right. So that's I think the biggest hurdle that I need to get through is basically convincing myself that, hey, we are going to be the people doing this. Right.
And I mean, you also have the big advantage of Vite being used in most of the major frameworks out there, right? There's just the odd one out. But
Yep.
yeah, that's also, I think, a big difference to other projects trying it beforehand.
Mm-hmm. Yeah, that's the main reason we were able to convince the investors. The main reason we believe we're in a position to do it. Right. I actually talk about this a little bit in the announcement blog post because the biggest challenge of a unified toolchain is the chicken and egg problem. If you don't have adoption, then you cannot really secure enough resources for you to complete the whole vision. But if you don't complete the vision, then people don't really want to use it. I think that was the situation for Rome. But for us, luckily, we already have Vite, right? So once we build it, we can get people using it by putting it into Vite. And we also use Vite as the opportunity to battle test it, making sure it actually lives up to the standards that makes people happy, right? So so I would say Vite helps us solve this chicken and egg problem.
Definitely. Someone asking, will Vite Rolldown OXC support TypeScript decorators?
Eventually, yes. The problem here is that there is a version of decorator in TypeScript that is in fact deprecated. there is a version of decorator that is on standards tracking type in JavaScript itself, right? So if we implement decorator support, it will likely be this new standard compliant version of it. And legacy decorators will depend on actual user demands.
Okay, makes sense. Yeah. So another fellow conference attendee is asking, how does it feel to bankrupt the CI business with like 1 second build times?
Well, we're still far from getting into every possible project out there, right? So hopefully newer projects will be easily using our build tools so that they get much faster build speed. I think a lot of the current CI business is based on the premise that there are existing large projects that stuck on older tooling, and also have a really hard time of migration off. So their near-term solution is to pay for some cache-in strategies, cloud cache-in and all that, in order to make things fast. But eventually, obviously, I hope that we can all collectively move on to something faster by nature. That would also make your build pipeline simpler without a cache-in middleman in the middle.
Got it. And so now we move a little bit more towards Vue, but also a bit towards Vite as well. So how do you go by managing a team and also still coding in parallel? How does it work out? I mean, the day only has 24 hours for all of us, right?
Yeah, it's getting more and more difficult, to be honest. But luckily, on the Vue side, we also have a lot of very active contributors in Vue core. So if you take a look at the Vue commits nowadays, most of the time I'm mostly merging work done by other people, right? So that's much easier compared to say me having to look at every single issue. So Edison and a few other newly joined team members have been doing a really good job at almost having PRs ready for every new issue very fast. And then I set up a pretty detailed review process of like how we categorize things, how we label things. So eventually, when things flow through to me, I can very efficiently take a look at what is ready to merge, what is ready to do. So I can squeeze the maintenance down to a very efficient period instead of having to keep my mind distracted in every direction every single day.
That makes sense. And that leads to the next question. I remember there was a discussion like 2023 also about you as a BDFL, benevolent dictator for life, can sometimes being the bottleneck. Are you happy with the velocity, with the Vue releases now as things go a bit faster? And as you said, like with you basically merging like the work other contributors doing effectively doing maintenance. How do you feel about the current situation of that?
So to be honest, I think Vue itself is now in a pretty good place in terms of feature completeness. So I don't think we want to play the game where we are like going to reinvent how things work or like coming up with crazy new paradigms, like forcing you to use server runtimes in order to do data fetching and all that stuff, right? So I think a nice benefit of that is a lot of the full stack innovations are being carried out by the Nux team. And I think that is nice because I like this sort of layered approach of our ecosystem where Vue Core is mostly focused on lower level improvements. For example, we make the parser faster, we make the reactivity system faster, we explore things like vapor mode, or we just focus on making things work better without forcing people to relearn things. I think that is the current focus of Vue. And Nux is, can handle a lot of like how to do better full stack development, data fetching, routing, and all the more framework level or meta framework level DX surrounding Nux itself, right? So I think that sort of each team kind of taking care of the right layer of abstraction is really nice. So I'm not really too concerned about the velocity because for the nice thing about Vue also is Vue is completely separate from this new company, from this new business endeavor, right? And Vue has been sustainable on itself for a very long time. So we're not really under pressure to say monetize Vue or trying to ship something by a certain deadline, right? And I think it's actually nice for open source project to be in that state, right? We don't want to, be constantly scrambling to come up with new things just to create hype or anything like that. Our focus is making sure Vue is able to serve its users well for a very, very long time to come, right? We've done so for 10 years, and I see that happening for another decade, maybe, right? And we want to do it at our own pace. We are not really trying to say, competing for attention or anything like that.
Makes sense. And also for like a question here that fits in there very well. Someone's concerned, will using Vue and also Vite stay completely free forever? Or are there any parts to monetize? That you partially answered that, but just to double down.
Yeah, they will be free in MIT forever, for sure. Everything we build as open source, they are meant to be open source, right? So the commercial part of the new company is more of an end-to-end tool chain that uses the open source bits and pieces. Like say, it will probably stitch together all the parts of OXC plus Rowdown plus Vite and Vitess maybe. So it becomes a kind of all-in-one, one-stop shop, which is going to be really, really strongly opinionated, right? So it's not going to be for everyone. It's mostly designed to cater to bigger companies or enterprises where they want strong consistency and standardization on their entire tooling stack, right? So that solves a different category of problems for pure open source consumers. So ideally, we want to be able to do it right by the open source community, but also find a sustainable business model so that we can use that sustainable business model to keep improving the open source parts.
Got it. So with all these things going on, as you mentioned yourself, you mentioned roll down, Vite, V-tests, Vue. Do you have the feeling that also giving the whole time management that like you can keep up with all of that, or you feel like that maybe you're burning more and more down in terms of all the work that's coming on, also giving the newly funded company in addition to what's all happening and everything around it? Or do you feel like the workload you can keep up with it, you're happy with it at the moment?
I think the most important thing to realize is I play a more of a manager role in a lot of these newer projects now. For example, like Vite, Rowdown, OXC, I don't really write code for these projects every day, right? Sometimes I may like in my own usage, I come up with small things. I may just fix it, but I'm not the daily driver of those projects anymore, right? We have dedicated team members doing the maintenance, working on new features. So in a way, the reason for building a company is so that I can scale myself to focus more on the vision and ideas and putting things together rather than spending most of my time figuring out small bug cases or edge cases and all that. Right. So that's a transition. It actually has been happening for quite a while now. And I think that's been working decently so far.
And Vue is the exception to that, you would say?
Yeah, I'm much more hands-on with Vue still, but Vue, as it stands, a lot of the work is also done by contributors through pull requests. Yeah.
Definitely. So you also mentioned that Vue as like almost feature complete, so to say. Would you say that like in Vue, the innovation part stops or has stopped a little bit, or do you still think, for example, Vue Vapor Mode as like an innovative bit coming out and more yet to come?
I think the biggest thing we're focusing on next will be Vapor Mode. So we've had some pretty decent performance breakthroughs just in the past week or so. So Zhizi is Kevin is going to be sharing a bit more details on Vapor Mode in VueFest at VueFest in Japan. He's been making a lot of new progress on that, and we can expect to see a beta release of Vapor probably by end of this year. Yeah.
Sweet. And the full release is TBA, I guess.
Yeah, TBA. So the full release, the biggest hurdle really is the mixed component graph. So we want to be able to run Vapor in VDOM and VDOM in Vapor. Right now, we can already run Vapor in VDOM, but not vice versa.
Got it. And I've seen maybe also some people in the audience have seen a tweet from Kazapon showing Vapor also working with, for example, Svelte. Is this also something that's actively pursued?
It's more of a kind of outbound exploration that's done by Kazupon, I think mostly for research and for fun and showing the capabilities of Vapor. But like as a project, as Vue itself, we don't really intend to say like, oh, let Vue power other frameworks.
Fair, yeah.
We don't really want to do that.
I mean, there could be worse things, right? Okay. Vue 3.5 brought a lot of custom element improvements, which kind of like, I wouldn't say came by surprise, but I remember when we talked in Deja Vu podcast, there was not much mention about it, and I was glad to see that. And someone was wondering if there are more features like access to the constructor for advanced features like form participation of custom elements soon in Vue.
Form participations? Did I hear that?
Yeah, form participation, exactly. It's like advanced custom element features and like almost better web component support, so to say. Even better.
I guess it's kind of vague, so it's probably easier if there is a GitHub issue or a thread that I can look at to get the full context.
Totally makes sense.
Because, yeah. It's
so
kind of
whoever
hard to
asked the
understand
question, write in GitHub issue. Like right now in the break. You know exactly. Yeah, then maybe let's start with, like I said, let's end it with a few lighthearted questions. Do you already know the name for Vue 3.6, the release name, whenever it will come?
I actually haven't decided yet.
Are there some close candidates so far in your head?
Let's say, yeah, I've actually written down the list of future code names I want to use, but it's not really set in stone.
Good. And are there any features for 3.6 that we can expect already? As like, hey, this is definitely something like, I don't know, stable suspense that we want to ship in the next minor, or anything like.
Yeah, stable suspense is one thing we do want to do. Actually, Edison has been systematically looking through all the suspense-related issues, and we are having basically an internal document that just like kind of lists all the current problems with suspense. And at one time, we'll have to just like look through all of them and see if there are any fundamental things we need to change. But if not, then likely it can be stabilized in 3.6.
Sweet. Anything else on the list is like, oh yeah, that's likely going to make the cut besides that?
Well, hopefully we can ship Vapor as part of Vue in 3.6. But so it will ship, but it will basically be in experimental state. Right? So you don't need to install a separate package to use Vapor. You can try it out as just part of proper Vue.
Sounds great. Yeah, I hope then also more people can share feedback, try it out, and it goes more and more towards a stable version. Lovely. Then as a very last question, and that's a more of a tricky one, especially in React, it's very common to use a meta framework like, I don't know, Remix, 10-Stack Star, whatever we have now, Next.js with React instead of just plain React. Would you recommend using Vue plain, or would you also go the same way and saying, hey, a meta framework should be the way to go, and if yes, why or why not?
If you look at, I think the idea that you need a meta framework to React largely has to do with how the React team and Vercel wants to push the mental model to sort of, because React 19 came up with this like, hey, this is how we're going to solve say, data fetching, streaming, suspense. It's a grand design scheme that they think is best manifested in the form of a meta framework. I personally do not 100% agree with that premise to begin with. I don't think you should force your users into one, just one way of building things. Like, I think SPAs are fine for a lot of use cases. Even a lot of React users kind of agree with that too, right? So that's why there are still a lot of new React SPAs being created with Vite. So yeah, I don't really think we'll ever tell people to say, hey, you should use Vue with the framework. It is up to you. It really highly depends on what you're trying to build, right? If you say you're building an internal dashboard that really doesn't make sense to be SSR'd, start with Vite and plain Vue. You can get pretty far, especially if your backend is not even in JavaScript. You have to work with an existing API, right? So in those cases, you should make the decision based on whether you really like the conventions or additional convenience brought by a meta framework, right? Because Nux, you can use Nux to build SPAs too, right? But Nux comes with a bit more opinionated the things like how to fetch data, do you want auto imports? Do you want auto font optimization? Do you want some of specific Nux modules, right? When you opt into a meta framework, you get these additional benefits. But if you really need those, then a simple SPA can still get you pretty far.
Or just using Vue in the script tag when you still have like an
you can
traditional
do that too.
SR application. So
yeah.
Great. Evan, thank you so much for joining for the talk and the Q&A. Thank you for everybody submitting questions. And give up a big applause for Evan Yu, everybody.
Thank you.